Now, I said that it's not a traditional formula because what you have to do is you have to choose these u and v values, right? And the guide to how to choose which one is going to be u is you want to think about, okay, when you look at this expression here, like where's the kind of complexity of this expression? Because we have this as uv dash, right? So this expression is going to be here is uv dash. And you look at these and, okay, if I want to find u and v, fair enough. But the complexity is in this part here, when you actually want to apply the integral. So you want to choose a u that gets simpler when you differentiate. That's the kind of idea. And you want to think about expressions you've differentiated before. You can differentiate a lot of different functions, right? Is there an order in which there's difficulty? Well, maybe not in terms of like the actual process of differentiating, but remember, you're not just differentiating. Once you differentiate, then you want to integrate, right? Okay, that's fair. The other thing to consider is, typically we choose u, right? But the result of choosing u, you have to choose a v actually as well anyway. If you look at this and you choose a v dash, you look over here and you realize that you have to integrate that, right? So you also want to be thinking about, okay, the v that I choose, I want to make sure that that's actually easily integratable. I don't know if that's actually a word, but easily integrable, right? So you look at this one over here and just kind of have a think to yourself, which one of these is kind of easy to differentiate and which one is harder to integrate is kind of what you want to be thinking. And that kind of naturally tends towards your choices, right? ln is hard to integrate. So that kind of leads you away from choosing like v dash as ln of x, right? And that's typically a guide for you to do that. That's something I want to keep in the back of your mind. There is a little kind of mnemonic trick that helps you choose. I just want to say that anytime with tricks, you just got to be careful because there's always going to be exceptions to those things, but it is a guide, okay? And it's a pretty helpful guide generally, right? So the guide is this. This is the order in which we can pick u. Light, yeah. There's some like variations of it.
That easy to remember.
There's another variation which is like I late, so I'm late. I don't know. This kind of sums up morning classes, right? But throwing shade at myself.
That is true.
But the idea is this, right? You pick u's in this order. So you have your logs, you have your inverse trig. And guess what A stands for?
Algebra.
Algebra. So
Yeah.
algebraic expressions, trigonometric functions, and it is exponentials. Now, there's some kind of intuition with this, right? So this is the order in which you pick u like the priority. So in like kind of descending order, you want to pick logs first. And naturally, if you go the other way, that's kind of like how you pick your u's, right? You pick your v's. But typically we use this for picking u's, right?
Why would we do the ln?
Yeah, so this is like your first priority, right?
U would be ln.
Yeah.
Yeah, that's right.
Yeah.
That's exactly what we do. Yeah, but like you can think of the order going the other way as picking v's, but typically we use this to pick the u's, right? And you can see why logs would be your first priority, right? Because logs are something that are easily differentiable, not very easy to integrate. The other thing you want to think about is when you actually pick the u, right, you're still multiplying it with something there. So you kind of want to pick something that may simplify out. So when you pick this as your u and you differentiate, you're going to get 1 on x, right? That has the potential to simplify with other kind of things, particularly in this kind of case, right? Can you guys see that? Yeah. So that's the kind of intuition with what's going on. Let's have a go. So when we're laying this out, here's our question. So we're going to integrate this guy, x cubed ln of x. Now, something I found when I was doing all the working out for this, it looks very similar to product rule. So I'm not sure if you want to like write to product rule, like when you're writing this out, like if you pick so we pick the u, we use this order here, right? So we see u is equal to ln of x, so it's a different order to the actual formula and how it's written, but make sure to use this kind of method. So we have u is equal to ln of x, u dash is equal to 1 on x. But when you're actually writing this out, because you're picking a v dash, like it looks very similar to product rule, except the orders are kind of mixed around a bit, right? Typically you'd pick a v and then get your v dash. So if you're gonna write it, the textbooks and like your work solutions may look very similar. Like you have v dash is equal to x cubed, and then v is equal to x to the 4, 1 on 4. When you're doing this, just be careful about when you actually put it in, because students tend to kind of mix these up because it looks kind of like product rule, but the positions are mixed around. So just kind of be aware of that, yeah? Does that kind of make sense? Or, no.
Okay, so yeah, we got the video.
Did I? Oh, yes, thank you. Please, call me out.
Running Lee 8.
Lee 8. Or E-tail, if you want to go backwards.
Yeah, e-tail makes a lot more sense. To be
E-tail
honest.
is
That's
Yeah.
should have done picking V, sir.
Should have done what?
Picking
We should
V.
have done V.
The picking V. All right, so let's do this out. So we have our UV. And so like I said, right, the UVs are now over here. So we've got 1 on 4 x to the 4 times ln of x minus the integral of vu dash. So we've got v and u dash. So you can see how these are going to simplify out quite nicely, right? So we've got 1 on 4 x to the 4 times 1 on x dx. And these will divide through. So I'll take the constant out as well.
So the way you do it, you treat
X cubed dx.
x cubed as already differentiated and then like
Yeah, that's right. So I pick, so I guess I'm not picking v, am I? I'm kind of picking v dash, so to speak, yeah? So that's why it's similar to product rule, but it's different. So you just got to be aware of that when you're putting these values in. Don't get confused between what's u and v.
differentiate, like integrate.
Yeah, that's right.
Interesting.
Cool. And then we see, now we can actually apply this integration here. Sorry, one thing I should also say, when we think about constants, technically there should be a constant over here, right? Because you're applying the integral process. But again, by convention, just to make things a bit simpler, we tend to leave that out until the very end because we're going to integrate here anyway, right? So it's 1 on 4 x4 ln of x. Take away, so we take the integral of this, so that becomes x to the 4, 1 on 4, plus our constant now. And we get something that looks like this. You could factorize as well if you wanted to. So, I mean, we can take out actually the 1 on 4 there if you want to make it a bit nicer. Or you can leave it as 1 on 16. Up to you. So if you want to take something out. Okay, so that's integration by parts, right? We have a general guideline of how to use it, as well as some ways of picking the variables, and then we can apply it through this method. Yeah.